As mentioned before, the AiiDA plugin ecosystem is one of the integral parts of AiiDA. So AiiDA really lives from its plugins. And so we did a questionnaire on the AiiDA mailing list last week. Giovanni already showed some results of it in his introductory presentation. And this is the statistics of the replies we got. So 27 research projects, I think in the end a bit more, and 25 plugins from people all over Europe, Japan, and so on. So what I'm going to talk about is first, what is a plugin? Then we are going to learn what Python entry points are, so essentially which you need to know in order to know how AiiDA discovers plugins. We're going to have a look at a demo plugin, and finally I'm going to spend a few words on how to develop plugins, also that if you don't attend my group, you have some idea of where to start. First of all, what is an AiiDA plugin? So an AiiDA plugin is a Python package that extends the functionality of aida-core. aida-core provides the basic infrastructure. It provides the database model, it provides the provenance graph, workflow engine, REST API, and more. So what can AiiDA plugins provide? AiiDA plugins can provide calculation plugins. They can provide parser plugins. And you have seen those as well. They can provide workflows. They can provide new data types. They can provide new Verdi commands. They can provide new schedulers. They can provide new types of transport, so the way of how AiiDA talks with the remote computer. And they can provide the database importers and exporters. And in the future, we want to extend the REST API as well, so that you can define specific REST endpoints for your plugin. If you go to the AiiDA plugin registry, you find a list of the plugins. So most of these are in the stage of aida-core 0.12. And if you look at the plugin, it doesn't show you just the name of the plugin and where it is hosted, but the plugin registry also knows some things about the functionality that this plugin provides. So for example, the ASE plugin provides one calculation and one parser. And the mechanism that we use for this is called Python entry points. Who has already heard of the term Python entry points? A few people. Who would feel comfortable explaining the problem they're trying to address and how they address it? That's the impression I get. And I'm going to try to give a simple explanation of how they work. Let's see whether we can change the situation. So the problem they're trying to address, I'm going to make this specific to AiiDA. So for example, AiiDA Siesta wants to provide a new SDM calculation. As a new user of AiiDA Siesta, how do I know where I need to import this from, right? So we could say AiiDA Siesta has a great documentation, so everything is documented. I look in the documentation, I import it. That is one solution. But now let's say AiiDA VASP, they want to provide a new VASP podcar data. And how do I add a Verdi command for VASP podcar data so that people who already know how to use Verdi can directly use this to inspect a podcar data node? Or how do I list all the workflows that I've installed on my machine? And there's many problems like this, and the overall problem is we want AiiDA plugins to be able to extend existing standard AiiDA interfaces so that people who already know how to use these interfaces don't have to learn again for every new plugin what to do. And now, what is a Python entry point? Python entry point associates Python objects with free-form identifiers, which just a string. So this is an example from the AiiDA diff demo plugin that we're going to look at in more detail later. This is kind of the entry points that this plugin provides. We're going to have a look at one of them. For example, it provides a new type of calculation called diff calculation. This can be, in this case, it's a class, but entry points can also point to functions, to variables, etc. Here is the free-form identifier, simply a string called diff. This here is the path in the AiiDA diff package to this class. And then there's a group called aida.calculations. These groups are defined by aida-core, and that is how AiiDA knows, AiiDA diff adds a new calculation of name diff, and if I want to get this calculation, I just need to look here. So how do I actually load a Python entry point on the console? There's a package called package resources that's part of the setup tools package in Python. And if you import this and then you say load entry point, you give it a distribution. It's the name of the plugin, AiiDA diff, a group, AiiDA calculations, and the name of the entry point, which is diff. You load this, you actually get the class back. And this is what the calculation factory diff that you've seen before or in different contexts does under the hood. So what can AiiDA plugins provide? For each of these plugins features, there are entry points defined in AiiDA, and you can add new entry points to it's groups. Sorry, I should have said groups defined by aida-core, and you can add new entry points to these groups. Just to mention that aida-core also uses entry points. So, for example, the type of transports that AiiDA defines is just local transport, the ones that we have been using now just to run on the local computer, and SSH, which is to connect to remote computers. We're actually planning to add a new type of transport that goes through REST APIs. So computing centers start to provide REST APIs to be able to run a job, check the status of a job, get files, and so on. We are planning to support this. And here's the list of schedulers that AiiDA supports. For example, the direct scheduler is just run it. But we have the LSF, PBS Pro, SG, Slurm, Torque. But if your specific computing center has some very custom scheduler that is not on this list, you provide a plugin for this scheduler. One word about re-entry. You might have already seen as part of the instructions that you have to do re-entry scan. So package resources provides the registry and lookup for entry points. But package resources does a number of integrity checks when it does this, and so it can be a bit slow. And we want to use entry points in the Verdi command line interface to, for example, be able to inspect a new type of data of a plugin. And so we need it to be quite responsive. And that is the reason why there, for existence for the reentry package. So it uses a separate entry point cache, and it's about 10 times faster. You don't need to worry about this, but this is the reason why you need to reentry scan after installing your package. Okay, so the AiiDA diff demo plugin. The AiiDA diff demo plugin is meant for you to get started with plugin development. So one thing you can do is you can just go to GitHub, clone this repository, and start modifying it. AiiDA diff wraps the diff executable. So diff simply computes the difference between two files. Right? The advantage of diff is that it's available on almost every Unix system, that it has some command line options, that it takes two input files and it produces one output file. So this is something that already covers a number of basic executables, and is a good point to start developing a plugin. And yeah, so I wanted to have a quick demo. Right. One thing I wanted to show is what you can do with a Verdi plugin list, which uses these entry points. So if you do Verdi plugin list, you will see all the available entry points. And groups, all the available groups that AiiDA defines. You can then look at, for example, which schedulers are made available by AiiDA. Or, for example, which calculations are currently installed. These are the calculations. And so you see I've installed this new diff calculation type. And what I can now do here is I add diff to the end of this command, so aida.calculations diff. And Sebastian has implemented a nice way of showing what actually this calculation plugin does. So it requires that it inputs a code, it requires an input file 1, it requires an input file 2, and some parameters. These are the command line parameters for the diff executable. And it produces an output file. plus all of these remote folder things that are necessary for SSHing. So this is a very nice way of looking in, if you do not remember like what inputs does a calculation type take. I'm interested to find this out. Use these commands. And let's have a quick look at what an AiiDA plugin actually is in terms of files. So this is on GitHub, in AiiDA team, the AiiDA diff repository. Let's have a quick look at the README. So this is actually the default output of an AiiDA plugin cutter. You've seen Sasha use a cookie cutter for AiiDA lab applications. We also have a cookie cutter for AiiDA plugins. And so what this will do is it will essentially, so if you want to, you already know you want to write a plugin for a new code named X. It will replace all occurrences of diff by X and will make sure that you have a bit less, spend less time in searching and replacing when you start with the plugin development. Let's have a, so here in this folder you see a number of files. Most of these files are not important if you get started with plugin development. You can let them sit there, and at some point when you advance further you will notice that they will be useful. But what we will have do now is we'll have a quick look inside the actual Python package, which is the AiiDA_diff folder. So what do we have in here? We have a Python file that contains the definition of the calculation class. We have a Python file that defines the parsers. We have a data folder. This is just to show that if you want, you can split. If let's say you have many types of data that you want to provide, you can also structure this in types of folders. And not everything has to be in a single file. You decide this how you want to do this for your plugin. And again, this init.py is just a Python convention. If you want to be able to import a folder, the folder needs to have an init.py. And one last thing I want to point out, okay, here's also, it provides some command line extensions, and very important, it has tests. So this brings me back to my presentation. Yeah, so some free time investment advice from me. Learn how to write tests. From my experience, scientists who start getting into programming are a bit hesitant to start writing tests because, and I understand why, right? So the way we usually get into that is we start writing scripts for ourselves, right? And we fiddle with the script, we make it work, and then it works, right? So why do I need to write a test to prove that it works? I know that the script works. But of course, the problem comes when you start modifying your script and want to use it, and you don't notice that you break some of it, or you want to give it to your coworker. And in general, when you write AiiDA plugins and you want AiiDA plugins to be usable not only by you, but also by other people, tests are super important, and tests are a big time saver. So it's a bit counterintuitive because you think, okay, I know I have to spend some extra minutes to write a test, but in the long term, I guarantee you it would save a lot of time. And so one particular testing framework that we recommend in AiiDA is a PyTest, and I've yet to meet a person that has tried PyTest and not liked it. So this brings me to plugin development and a few basic design guidelines. So the first one is start simple. Your plugin does not have to start with a copy of the AiiDA Quantum Espresso plugin. Use existing classes, so you don't need to define your own class in the very beginning. You can use the dict class to give, for example, command line parameters to your executable. You can use the single file data class to get output files back. And start with writing only what is necessary to pass information to AiiDA and get it back. Then the second important point is don't break data provenance. So the minimum information that you need to store is what is needed for full reproducibility. And that is partly your responsibility as the plugin developer. Finally, third point, so parse what you want to query for. So it's very helpful to make a list of the kind of information that you want to query for. this should go into the database that should be parsed, for example, in a dict node. And then the files that you want to store on disk you can keep locally for reproducibility or for other purposes that are maybe too large to parse, or maybe it's something that you will never want to query for, like a single value in the Kohn-Sham wave function. You're not going to want to query for that, but it might make sense in some circumstances to store it. That is a decision that you need to make as a plugin developer. And finally, what are the informations that you will leave in the supercomputer, and you don't care essentially if they're deleted because you can easily reproduce them. So for example, the Quantum Espresso plugin will leave the Kohn-Sham wave functions and the charge density on the supercomputer. And if at some point you want to reproduce the calculation, you have all the inputs that are necessary to reproduce it. And finally, expose the full functionality of your code. This is important, so don't try to artificially limit what the code can do, or users will get frustrated. Right? So they know the code can do this, but the AiiDA plugin cannot do this. The idea of an AiiDA plugin is to provide interfaces to all possible ways of using the code. Not all of them have to be done in the same way, and you can somehow give users extra ways of doing things if you don't have time to parse everything in the best way, but don't limit what the user can do. This is very different from workflows, right? The idea in a workflow is you have one specific purpose, you make it work for that purpose, and you try to limit the possible amounts of inputs that a user needs to run the workflow. A plugin should be an interface to the code that is as general as possible. A few words on the transition to aida-core 1.0. So there were many API changes in AiiDA from 0.12 to 1.0. And we did a plugin developer week in March, helping plugin developers to migrate to 1.0. However, although we are now at the beta version, the main message should be the AiiDA API should remain stable from aida-core 1.00 beta 2. So if we discover at some point a big problem in the API that we cannot solve without making an API change, we might change something until 1.0, but this is really the big exception. So the idea is from beta 2, the API should be stable. And we're now at beta 3. Some helpful resources you can have on the AiiDA tutorials page at the bottom. If you scroll to the bottom, there is a collection of videos from this developer workshop with advice on how to migrate plugins. Then, very useful on the aida-core wiki. By the way, we have a wiki with some interesting information like a release roadmap, Git cheat sheet, and and the AiiDA 1.0 plugin migration guide. It has step-by-step instructions of how to migrate a plugin from 0.12 to 1.0. And if you do it, you will notice that you can actually delete a lot of code. So one of the advantages of migrating to 1.0 is that the amount of code you have to maintain will reduce quite dramatically. So this is the stage of the migration of the plugins that from authors that were at the workshop. So one important point I wanted to make here is if the plugin of interest is not on this list here, then you probably don't want to go into the workflow group, but then you probably want to go into my group and learn how to write the plugin or how to migrate it. These are the plugins that have some have basic compatibility with AiiDA 1.0, and that you should be able to use for writing plugins in working group A. So not only the ones with tick marks, these are the ones that have made releases. Many of them have at this stage where they work in a particular branch, but that should be okay. Finally, a few practical guidelines. So you want to get started with plugin development. Check on the AiiDA plugin registry that your desired plugin name is still available. Use the AiiDA plugin cutter to jumpstart your plugin. And finally, get your new plugin registered on the plugin registry. So it's important that you do this not when the plugin is ready, right? Do this when you start development, because this will show other people that you are working on this, and people will contact you and say, okay, can I help? There's an issue with this, and so on. So this is really one of the benefits that we have in academia. We can be fully open, and we should profit as much as we can from this. As I said, write tests for your plugin. And finally, take advantage of free continuous integration platforms. So this is just a very convenient way of always making sure that all your tests pass, and we will cover this in Group B. So in Group B, we are going to, the plan is to go through the plugin cutter, how to get your new plugin registered, how to test plugins. We will get an introduction from Alberto into how they decided to design AiiDA Siesta. We'll have maybe some comments on pre-commit hooks and integrated development environments. Yeah, so there will be 4 tutors to assist you. So this brings me to the end. AiiDA plugins are Python packages that extend existing AiiDA interfaces through Python entry points. And when developing a new plugin, start simple. Don't start from scratch. Use Git for version control. I didn't mention this. And GitHub for collaboration. And write tests. And with this, let me thank the many developers of aida-core and Materials Cloud that are listed here, and the contributors of the more than 30 plugins that we have on the AiiDA mailing list. Thank you for your attention. Questions? And we have a mic, I think. Is it on? He cannot have. Yeah, it works.
Questions?
Thanks for the talk, and it's very interesting the focus that you gave for the test. Do you have some guidelines of what should be tested and what, in your experience of designing plugins, and what an user should expect in the test? Because I mean, there are 2 phases: something that you would like to test, but also something that when you use, you would like to find in a test. Do you have some thumb rules of what to include there, or thumbs that maybe you start in some way and then you change because you find it more advantageous? So sharing this kind of experience.
I mean, there are different approaches to testing, right? So on the one hand, for example, there's the unit testing approach, where you try to test every individual function on its own, which scales well in the sense that with this you can really cover, with the combination of these types of tests, you can cover a relatively broad spectrum of the possible use cases of your plugin. On the other hand, there are integration tests. So in the case of AiiDA plugins, that would be simply, for example, setting up a calculation, providing some inputs, running everything, checking that the outputs are fine. This has the advantage that in one test you cover a lot of the possible code, but of course you don't cover as much diversity. So these are some things that, there's something that you need to decide on your own. For example, the AiiDA diff plugin has 1 integration test and has a number of unit tests. If other people have suggestions.
Yeah, some comments there. So the difficulty with integration tests is that you might write one and then basically running through a whole calculation with a parser, but you will then typically select one set of inputs. But your calculation might behave very differently if you change one input or you have an extra option, and so all that part of the code will not even be touched, right? So with integration tests, if you want to follow all the possible branches, you have to have many of those different sets of inputs that test everything. And in AiiDA, this is especially difficult because each integration test will require actually running through the actual code. And often this is difficult because even if you run this on these continuous integration platforms like Travis, if you want to test CP2K, for example, you need to have CP2K installed on that remote and all the other things that are required, and this is pretty difficult to do. So,
So by default it's difficult, but if your code is open source, we start doing this. So I mean.
But even so, I mean, you're not actually wanting to test CP2K, and still your unit test takes all the time that it needs to wait for that to be executed.
The integration test.
In the integration test. So we also have this problem, of course, with the Quantum Espresso plugin, and I've been working the last few weeks on adding more testing coming up through PyTest, ways to basically circumvent this. And already for an integration test for calculation is basically running the calculation through AiiDA and then parsing the results. I split those in two. And so for the parser testing now, I just have a predefined set of outputs, and I pass those to the parser, so I don't actually have to run the code. And I do the same for the calculation. The part that I'm interested in AiiDA is not to run the actual code. I would just want to make sure that if I pass a certain set of AiiDA inputs, that the plugin writes the correct input files, writes the correct instructions, okay, you need to copy these files over, you need to retrieve those files. And also that doesn't require running the code. And so now, using PyTest, these have become actually very easy, because now I can run them on Travis. I don't have to do any installation. I don't even have to set up the database, because AiiDA does this automatically for you. So we haven't documented these approaches, because we're discovering these as we go, but we can show these how these work, and you can copy-paste in a sense.
So wanted to add a comment. So as Sebastian said, in the end, the important thing to remember, you don't want to test other codes. So even if you rely on CP2K, Quantum Espresso, you first don't need to, because sometimes it's expensive. Second, you don't want to, because if they break something, then your test fails, which is not what you want to test. My feeling, and in general, you want to have as many unit tests as possible, because they scale not exponentially with the number of combinations. But still, I would say, if it's a relatively complex thing, you want to have maybe at least one integration test to see that not only the individual pieces work, but also if you run a full thing works. Of course, again, this is true for AiiDA. For instance, in AiiDA plugin, maybe you don't want to test AiiDA in a sense, so you should assume AiiDA works. Because then if we break something into AiiDA, then if you test failure, it's not what you want. So it depends a bit case by case.
Thank you very much.